Hi folks, so the question we have in front of us here today, guys, is from the DCG Solutions workbook. It is on page 112 and it's on the topic of oblique planes, sheet 12, okay? And what we're going to be doing specifically is working with true shapes and rebatment, okay, which we have done a bit on before. Only in this case, where this question is a bit different, is they've given us the true shape already and the rebatment completed, and what we have to do is work backwards to get the elevation and the plan of this kind of cut surface here, okay? So we can see obviously the cut surface here is roughly based off a pentagon, and what we have to do is we have to get what the pentagon would appear as in our plan view and in our elevation, okay? And what we also have to do is, you can see here they've given us the horizontal trace, but we have to find the vertical trace. So it's a case of using the knowledge that we have already learned to work backwards. So just read the question here. It says the surface of a cut solid rests on an oblique plane VTH. The oblique plane has been rebatted onto the horizontal plane, so it's sitting on the ground now, to show the true shape of the surface. So we can see the true shape here as it has been rebatted down, sitting on the surface. Given the rebatted V1TH, locate the vertical trace and complete the projections of the oblique plane VTH, and then produce a plan and elevation of the cut surface. So we'll start with the first one. We want to locate the vertical trace up here to complete the projections of our vertical trace and our horizontal trace, or VTH as we always know them. Okay? So to do that, guys, we're just going to work backwards. Often when we're given the VTH up here and we have to get the V1 down here, okay? What we usually do is we take a random height, okay, or a point up here, from anywhere along the XY line up to hit a point on the vertical trace. And at that point there, we usually rebat it around, rotate it around until it comes down here. And then where that mark was, where we did that line, we rebat around. But where the mark was here on the on the XY line, what we do was we went perpendicular to the horizontal trace out, and where it cuts through that rotated line, that gives us a point on the vertical trace down here, the V1, okay? So we're just going to do that working backwards. So what I'm going to do is I'm going to randomly pick a point, okay? I'm going to put this in green now. And I'm going to randomly pick a point, doesn't matter, anywhere along the line, and I'll put it in, pick around here, somewhere like that, a point right there, okay? So that point right there. And what I'm going to do is I'm going to go perpendicular from that point to the horizontal trace. So set up on my horizontal trace. My other set square is underneath it, and I'm just going to slide it that way, or rotate it I should say. And that there, guys, is perpendicular. That angle in there, okay? So as we can see, it's perpendicular. Where it hits our XY line, what we're going to do now is we're just going to project up straight, okay? So I'm using green for this, guys. This is just the explanation. And somewhere up along there is going to be a point on my vertical trace. And we know, having done that, what we can actually do now, I'll switch out my pen here and I'll stick on the green. Okay. We know, using T as our compass point, out to the point on the vertical trace down here when it has been rebatted, if we rotate that back, where it cuts through up there, probably extended a bit too far up, but where it cuts through the vertical line going up, that is a point on our vertical trace, okay, in the elevation view, okay, on the vertical plane. So that is where our oblique plane is cutting through on the vertical plane. So I have now found my VTH. First part of the question done, just applying the principles that we already know, but just using them to work backwards, okay? So the next part now is we're going to have to produce a plan and elevation of the cut surface, okay? So I'm going to label this here. I'm going to call it points 1 to 5, or you could do A, B, C, D, E. I'll actually use letters in this case this time. So I'm going to start here at this one. I'm going to call it A. I'm going to call this one B, C, D, and E. Okay, and technically now these might be actually, because it's I'll say they're D1, C1, working backwards, and then we would have the original A, B, C, D, E in here, in here and up here, okay? So I've got A1, B1, C1, D1, E1. Now what we're going to do is usually what we did previously when we got this, okay, we would have had a surface up here, A, B, C, D, E, and we would have projected across horizontal to hit the vertical trace. Wherever the point was on the vertical trace, let's say for D1, we would have rebatted it around. Okay, so for D1 it would have been closer, it would have been down here somewhere, I'd imagine. We would have rebatted it around where it hits here, we would have gone parallel to the horizontal trace, and from the point here, we would have come out perpendicular to locate it. That was one method. The other method we used, and I've done it previously, okay, on the last video I did, was where we kind of used this rectangle method. And that's the one we're actually going to have to use, because the problem is here, we don't have any kind of designated lengths for them, okay, at this moment. Like I could take, technically, for D and E, I think they're actually parallel with the horizontal trace here, but for D1 and E1, I could project them back. Okay, I'll actually do it there just to show you why I have to use one method over the other. So for D here, I'm going to go parallel to the horizontal trace. As you can see there, E1 is on it as well, so I'm happy with that. So I'll go parallel to the horizontal trace. Where it hits there on my V1T, okay, on my V1T, I would rotate that around. When I say rotate, I mean rebat. And it hits my vertical trace right here. Where it hits the vertical trace right there, what we usually would do is we would project across. I'm just guessing now it's going to be somewhere up here. We project across, but we don't know exactly where along there is our point. Okay, so we can't actually find it in elevation first. We actually have to find this structure in our plan first before we find it in our elevation. So that was working backwards, but we're kind of missing a step to be able to complete it here. Okay, so what we're going to do now is we're going to use another method, and we're going to go parallel, like we did yesterday. It's kind of the rectangle method, I call it. So from here, we're going to go parallel to the horizontal trace, which we've already done. So the relationship between this line and this line is that they're parallel. Where it hits my V1T, I'm going to go perpendicular. Okay, so nice and easy. I'm going to set this up. And once I've it set up once, I might only have to change it maybe once or twice. So parallel to the horizontal trace, step 1. Step 2, to the horizontal trace to hit the XY line. Hits the XY line here. Step 3, parallel to the horizontal trace from where it hit the XY line. Step 4, perpendicular to the horizontal trace. So, step 1, parallel to the horizontal trace to hit the V1T. Step 2, perpendicular to the horizontal trace from where it hit the V1T to hit the XY line. Step 3, from where it hits the XY line, parallel to the horizontal trace. And step 4, from D1 in your rebatted view, perpendicular. Okay, so you can see here we essentially just have a rectangle. Okay, and what that actually helps us find is the point D in our plan view. Okay, so I'm going to do the exact same method now with E, and I know D and E are actually on the same, so extend that down and extend D out, or E out I should say. So right there now I have found E. So there's E. I'm going to do the same now for A and C, because I think the way this is working out, A and C will be in line with each other. Yeah, they are. Happy with that. So, parallel to the horizontal trace to hit the V1T, perpendicular from where it hits the V1T. Okay, perpendicular to the horizontal trace to where it hits the XY line. Where it hits the XY line, I'm going to project down parallel to the horizontal trace, getting down far enough so I can get both points. And then for C, or I should say C1, perpendicular to the horizontal trace, that's going to give me C1, and the exact same then for A. So locate those. There's A, that point there is C, and last one then that I have to do is finally B1. So from B1, parallel to the horizontal trace, where it hits the vertical trace V1T, project up perpendicular to the horizontal trace, where it hits the XY line, parallel to the horizontal trace, and then from where it has been rebatted, straight it back up. There we have it. Okay, so there is our plan view technically of our cut surface. So I'll actually heavy all that in now. Just going to heavy this in, connect this up, connect A up, A to B to C, C to D. Okay. Now having done this, we actually can do it a couple of ways, okay? We could go back to this rebatment method. So if I go back to my original D and E, just to show you, so D and E, sorry, D1 and E1, went up here, where they hit the V1T, where the rebatted vertical trace, I'm going to rebat them back around, and somewhere along here is actually going to be my points for D and E. And we know then at that point, it's very simple here, we can literally just project up perpendicular. Okay, so I can just project up perpendicular. So for D, it's going to be right up there. Okay, and the exact same for E. Just have to extend the line over a little bit. And there we have it. There is our elevation of both D and E. Now the other method we could do, okay, and you'll probably see, you can actually nearly see it already, is that if I had D and E, we could use just simple point location. For E and D, because they're on the same line, I can project up parallel to the horizontal trace, normal point location method. Where it hits the XY line, project up to the vertical trace. You can see it matches up. And where it matches up and hits the vertical trace, across. Okay, so that's the way I'm going to do it now for A and C. So it has already gone up parallel to the horizontal trace, where it hits the XY line. Okay, I just find this method quicker than obviously using the compass. Where it hits the XY line, project up to where it hits the vertical trace. Where it hits the vertical trace, horizontally across. Just bring it across far enough so that I think I might have to go just a touch further. Maybe a little bit further there. So now for C, project up. There's my C, and the exact same then for my A. Probably had it just enough. So there is C, and there is A. And now finally do the same for B. Because we've already projected parallel, it's easy, okay? So where it hits the XY line, project up. And I'll actually project this up while I'm at it. It's going to be somewhere up here. And then where it hits the vertical trace, project across. And there we have it. That is our B in elevation. Having found that, we can now draw in our structure or our surface A, B, C, D, E in elevation. So just heavy those in. And finally, last one from B down to A. Okay, so as you can see there, guys, it's basically they've just given us the cut solid, okay, and they give us the rebatted kind of portion of it to get the true shape. If you imagine, I'd imagine looking in down here, okay, looking in at the top of it, A was to continue down to the ground, okay, so this is obviously a pentagonal prism, okay, A would have continued down to the ground here, so I'll actually just draw it in, might as well. It's not part of the question, we weren't asked for it, but A would have continued to the ground, D and E would have been at the front as well as we looked in. This is the elevation view, because remember, as you were looking in this way at it, you would have seen the edge A, you would have seen the edge E, you would have seen the edge D as it went down to the ground. C would have been at the back, as would B, so these guys would have been in as hidden detail. Now they haven't asked us for that, it's not relevant to the question, they haven't asked us for this, but it's just showing you here kind of a 3D version of what it would look like. And you can see then clearly where the oblique plane has obviously cut our surface. Okay, so that's the question part 1 done of this one, guys. Literally just working backwards. Okay, so I hope you found that helpful. We're going to move on to part 2 now, where it's the exact same process. Okay. Right guys, so part 2 on this page again, okay, so we can see here it says a lamina rests on the oblique plane VTH, okay, so we can see that there. The oblique plane has been rebatted onto the horizontal plane to show the true shape of the surface. So we see this surface here, kind of 4-pointed surface. Given the we're given the rebatted plane V1TH. Okay, so we can see that the VTH, we haven't got the V up here, the vertical trace, but we can see that the rebatted vertical trace, when it has been down in plane, showing the true shape of this cut surface here, or the lamina that's resting on it. Okay, they're saying it's a lamina this time. So what we have to do once again is locate the vertical trace and complete the projections of the oblique plane VTH, and then produce the plan and elevation of the lamina. Okay, so the exact same method as we previously done on this question over here, we're going to do the same process again. Okay, so it's good practice. So working backwards once again, I'm going to put this in green first. So anywhere along this V1T, I'm going to pick a point. Okay, now I could pick it far down here and project up perpendicular, so I'll actually go, just thinking, yeah, I'll come down far enough. You don't have to. Actually, do you know what? I'm going to come inside about here. I'm going to pick a point right there. Okay. At that point, I'm going to project up perpendicular to my horizontal trace, like we did the last time, to the XY line. So perpendicular to the horizontal trace. Okay. Where it hits the XY line, put that in. Pen is dying on me. Where it hits the XY line, what I'm now going to do is project up vertical. Just thinking, I'll probably come in somewhere around here, I'm guessing. Okay, so at that point then, I'll just switch out my pen here. At that point, using T as my compass point, okay, I'm going to rebat the vertical V1T back around. Now, we usually rebat and we go around in this direction, okay, kind of clockwise. However, because that's going into the other drawing, I want to keep that neat and tidy. It's very, very easy for me just to take that distance there. You don't always have to rebat it and draw in the arc completely. You could just make a mark, okay? Or I could have actually drawn in the arc like that as well, okay? So I'm just going to make a mark this time, nice and easy. Keep it neat and tidy. And just have to extend up my vertical line. I was quite close, just a little bit further. And there you have it, where the two of them cross each other. That is a point on my vertical trace. So connect that back. There we have it. That is our oblique plane VTH. So now what we have to do, once again, kind of like the last question, we are going to label this guy here. This time I'll stick with the letters actually, so I'm going to go A, B, C, and D. Okay, and this time we're going to do the exact same method. So we're going to go use kind of the rectangle method, where we're going to go parallel and then perpendicular. Okay, so setting up parallel to my horizontal trace first. Once you've just done once, it's easy, just get them all done. So I'll start with D, the closest one. Parallel to the horizontal trace to hit the V1T. Where it hits the V1T, perpendicular. And of course then I wouldn't have enough room, so I'll extend it out a little bit further. Hopefully this will work. So there we have it. So where it hits that, perpendicular to the horizontal trace to hit the XY line. Where it hits the XY line, projected parallel to the horizontal trace, and then just bring it far enough so that you know then that you can find it. Whoop, slips there. There we have it. That is our point in our plan view found. So there is D. And now I'm going to do the same for C. Parallel, perpendicular. Where it hits the XY line, parallel to the horizontal trace. And finally, perpendicular. Okay, now found C. Next one I'll do is A. Just working my way backwards. Parallel to the horizontal trace to hit the V1T. Where it hits the V1T, perpendicular until it hits the XY line. Where it hits the XY line, parallel, Might have to extend this one a bit further. I think I will, for both of them. So just move these, extend that one, and extend that one. So there we have our A. And finally, last one. Okay, just make sure I'm still parallel there. I am. So parallel from B to the horizontal trace, where it hits the V1T, project up perpendicular to hit the XY line. Hits the XY line, project parallel. And finally, project B back perpendicular. There we have it. There's our points. And so A connects to B, B connects up to C, C to D, and D back to A. So there's our lamina, plan view of our lamina. Now, having found the plan view, it's very easy. We can just find the elevation by using simple point location method. So the lines have already all been projected up parallel. So at this point, let's say I wanted to find B. Okay, projected up parallel to the horizontal trace, vertically up to hit the vertical trace. I'll bring up B up here as well, just so I can be able to find it. And then where I hit the vertical trace, horizontally across, there is my B in my elevation. Okay, this here is by using the horizontal cutting plane, horizontal cut method. Okay, because the horizontal cuts will appear horizontal in our plan view where they're cutting through that oblique plane. So B is done. Next one I'll do is A. So just bring it up far enough as I think I might need it. Somewhere about there, I'm guessing. So make sure I have the right one. Yeah, here. And where it hits the vertical trace, project it across. I have to go a little bit higher. And there we have A. And finally go on to C. So project up. Where it hits the vertical trace, across. There's our C, and the last one then is our D. So you can see D here parallel to the horizontal trace to hit the XY line. Where it hits the XY line, project up perpendicular. So just so I know I'm going far enough. There we go. And then finally project up D, just inside the B there. So there's our D in our elevation. So once again, it's simply a case of connect the points to each other, just to get, the lamina drawn in. A to B, B to C, C to D, D back to A. So there you have it, guys. That is the elevation and plan view completed of our lamina. The other method then obviously that you could have done there for the point location, probably a little bit more work, but you could have from T, let's say we'll just work it out for D here. If I were back this around where D went parallel and I hit the V1T, so about there, bar was out a little bit long, I could have rebatted that and it should match up, hopefully. And you can see it does. Okay, having rebatted D around matches up here where it hit the VT trace, the vertical trace, hit there, we went horizontally across. Okay, but it was much easier and much faster having done this line parallel already to just project up perpendicular and bring it across. Okay, or project up vertically. That's those questions done, guys. Hope you found them helpful, and we will move on to the next page in another video. Okay.